All right, greetings everyone. Welcome to Back to Basics. What is that you are looking at now? I want us to look and understand our functional isomers, right? Basically, now functional isomers in simple terms, basically it is going to be what? It is going to be those molecules which are having the what? Which are still having the same molecular formula, right? Molecular formula, but now what is going to be different here, right? This is going to be same molecular formula, but different what? But different in functional group, right? But different functional group. What is this supposed to mean? Let's see now. Now look, firstly, in order for us to understand this, let's start here. Now, for an example, if you can look at these following functional groups, if you can look at your ketone, for an example. Now, your ketone, we all know that your ketone, the functional group of your ketone, it is always going to be found where your double bonded O oxygen is always going to be found in between the carbons, right? So we are saying the oxygen, right, that is bonded with the carbon must or rather the carbon that is bonded with an oxygen must always be bonded with another two carbons on the side, right? Now, but what happens if you move this double bonded oxygen here to the side or at the tip? Now, as soon as you, for an example, take this, right? Let's say as soon as you take this particular double bonded oxygen and you are moving it to the side or to the carbon that is found at the tip, what will happen? For example, if this is like this now, this is like this, what will happen? Basically, you can see that now, if this is found at the tip, now, if the oxygen is found at the tip, what is this going to be now? Now, this is going to change. Now, this is no longer going to be your ketone, but now this is going to be your aldehyde, right? This is going to be your aldehydes. Altogether. So basically, now under functional isomers, you are going to have your ketones, which are going to be changing either from ketone to aldehydes or aldehyde to ketone. Why are we saying that? Because these are going to have the same structural formula, right? Or rather, these are going to have the same structural formula. Now, what will be just different is that now, if you are moving the double bonded oxygen to the tip of your carbon, right, or to the carbon that is found at the end of your what, of your chain, this now is going to change from it being a ketone to what, to be an aldehyde. Similarly, if you are moving an aldehyde, which is always found at the tip of your carbon chain, right, it is always going to be now your ketone. As soon as you move it to your middle, it is going to become your ketone, right? I want us to, try and examine this. Now, for an example, let's say now I give you that you are having what, your propanoic acid, right? Uh before that, let's see. Before that, let's start with this one. Let's say now I give you that you are having your let's say I give you that you are having your but let's say you are having your butan. uh let's say you're having your butan. This is going to be your what, your butan 2-one out again. Now, this is going to be your butan 2-one. And now from here, after your butan 2-one, I tell you that you are also now going to have what? Now, let's say I tell you that now, from here, let's start by drawing the structure. This is going to be the structure, right? Whereby your double bonded oxygen is going to be found at here, right? It's going to be found in here. So, which means this is going to be your hydrogen, right? Out again. Now, which means now from here, let's say now if let's say now you are moving this, right? Let's say now we are moving this particular double bonded oxygen here. If let's say we are moving it now here, remember we said functional isomers, it's going to be different in terms of what, of functional group. If you are moving this double bonded oxygen here, right, what is going to be this one? Now this is going to change from it being a your butan 2-one, and this is going to become what? Now this is going to be your or this is going to be your butan, or your butanal. This is going to be your butanal. Why are we saying that? Remember, when you are taking the double bonded oxygen to or at the end of the carbon, it is going to change it from it being a ketone to be an aldehyde, which means now the new structural formula here, this is going to be what? This is going to be like this. Now, this is going to be this found in here, right? If this now is found in here, and now here, this is going to be, right? Let's just add your hydrogens here, your hydrogens here, your hydrogens here, right? Now, so which means now, can you see that now as soon as this is found here at the end, right? Or as soon as this is found at the tip, now it changes, right? Its functional group, right? From it being a what? From it being a ketone to it being a what? To it being a a what for to it being an aldehyde rather, right? Now, but if you can check the structural formula for these right now, now the structural formulas here is still going to be same as what is this butte? This is going to be C4. And then what is going to be the H? This is going to be your H. How many hydrogens are you going to be having here? This is going to be 1, 2, 3, 4, 5, right? 6, 7, 8. So this is going to be 8. And this is going to be your O, right? Out again. Now, similarly here, the structural formula or the molecular formula is still going to be the same thing. Out again, right? So what changed now? It was simply the what? It was simply the what? It was simply the uh your your functional group. Are we together? Now let's check another examples here. Right now, another two isomers, or rather another two functional isomers that we are having your carboxylic acid and also your ester, right? The carboxylic acid and also your ester, they are having the same condition with your what? With your ketone and also your aldehyde. Remember your carboxylic acid, remember the functional group of your carboxylic acid, it's like this, right? And it's always going to be found at the tip, where here it's going to be the reactants that are continuing out again. Now, but now if let's say you move this now, remember this is your carboxylic acid, right? Carboxylic acid. Now, if you move this functional group now to the middle, remember if you move this to your middle, let's say you move it here. Now, let's say this is going to be found here, and now you're having your carbon here, and let's say you're also having your carbon here. Now, this one no longer becomes your carboxylic acid, right? Now, but now this is going to become your what? Now, this is going to become your ester, right? This is going to become your ester, which is formed through esterification, right? Now, this is going to become your ester. Now, I want us to look at your examples here. Now, let's say I give you this example. Let's say now you are checking your propanoic acid. Let's say you have your propanoic acid, propanoic acid. Now, let's draw our structural formula for propanoic acid. Your propanoic acid, remember, this is prop means 3. This is going to be 1, 2, 3, right? And now this is going to be obviously the double bonded oxygen here. And this is going to be like this, right? Now, I want us to look at these. I want us to check all of these and see in terms of now, if you say, let's say you're having your propanoic acid, now you decide now that you are going to move now the functional group here to the carbon that is in the middle. As soon as you move the functional group to the carbon that is in the middle, already now the functional group here is going to change now from it being a carboxylic acid to it being a what? To it being an ester. For an example, if you are moving it here, now what will happen if you are moving it to the carbon that is in the middle? What will happen here? For an example, this is going to be something like this, right? This is going to be something like this. The name will completely change. Now, the name will completely change. What will be the name of this now? The name of this now will become what? Remember here, this is going to be your ester, and your ester is made up of what? This is going to be the alcohol side, right? This is going to be your alcohol side, and your ester here, this side is going to be what? This is going to be your carboxylic acid side, right? This is going to be a carboxylic acid side, which means now the new name that you are going to be having here now, this is going to be your methyl ethanoate, right? Now, for an example, this is going to be your methyl ethanoate, isn't it so? This is going to be your methyl ethanoate, right? Ethanoate. And what does this basically mean now? But this means now the functional group of these have changed. But what you just did yourself, you just moved your O's here to the middle. And by you moving that, you are changing the functional group completely. Now, but I want us to now examine and check in terms of, is this still going to have the same functional, is this still going to have the same general formula? Now, the general formula in here is still going to be the same, right? Why are we saying that? For an example, what is it that you are going to have here? You are having 3 carbons, right? So this is going to be 3 carbons, and now your hydrogens that you are having here, they are 6. So this is H6, and now you are going to have 2 oxygen. This is going to be your O2, right? Now on this other side, what is it that you are going to have? Again, you are still having your carbons, which are 3, your hydrogens, which are 6, and your oxygens, they are also still 2. Are we together? Which means now what changed basically, it was the what? It is the functional group, but the what? But the functional, or rather, but the molecular formula remained the same. The only thing that was changed, or the only thing that changed, it was the what? It was only the functional group. So basically, this is what we mean when we are referring to our functional isomers. Hopefully, this makes sense. Thank you very much.